And welcome back, students. As we jump into our new unit, we are going to this time be talking about recursion. So in order to talk about recursion, let's jump right in, talk about recursive void methods, and we're going to start off by discussing how to trace a recursive call. So getting started here, a method that includes a call to itself is said to be recursive. So that means inside the method definition, you would put the name of the method. So let's just say we had a method called like random int, which just generates a random integer. And inside of that, you have a call to itself, so it constantly is generating itself. Right, obviously, that's not the best example, but just kind of inside your method definition, whatever the name of that method is, you're going to have that inside. And we'll see that as we go along here. Now, like most modern programming languages, Java allows methods to be recursive by nature. And if this is used with a little bit of care, it can actually be a very useful programming technique. Now in this unit, we're going to discuss the basic techniques that are needed for defining successful recursive methods. There's nothing in this unit that's truly unique to Java. Other languages will handle recursion as well, such as C#, C++, etc. Now note, we're not really going to be learning any new Java elements here. So there's not going to be like, for example, when we talk about file I/O, we had the I/O classes. We talked about all that stuff. We talked about exception handling. We talked about things like derived classes. We talked about how to add that code in there. Now here with this, we're not really adding new code as we're adding new techniques. Alright, so let's jump right in and discuss that recursive void method. So when you're writing a method to solve a task, one basic design technique is to break that task into subtasks. Sometimes it turns out that the subtask is a small example of the same task. So for example, if the task is search a list for a particular value, you might divide the subtask into searching the first half list, and the subtask is searching the second half list. Well, the subtask is searching the halves of the list are smaller versions of the original task. Whenever one subtask is a small version of the original task to be accomplished, you can solve the original task by using a recursive method. So let's begin with a simple example in order to illustrate this technique. For simplicity, our examples are static methods. However, recursive methods don't have to be static. All right, you can create objects for them and use them that way. Now in Java, method definition may contain an indication of the method being defined. In such cases, of course, as we mentioned previously, the method is defined to be recursive. So here's our example, vertical numbers. All right, Recursion Demo 1 contains a demonstration program for a recursive method named writeVertical, which takes one non-negative int argument and writes that into the screen with the digits going down the screen one line. So for example, the invocation writeVertical 1, 2, 3, 4 would produce the output 1, 2, 3, 4. All right, and if we take a look at that program here, I'm just going to pop over to Clips real quick. You can see it's a very simple program here. All right, so we have system.println writeVertical 3. This is writeVertical 3. System.println writeVertical 12, writeVertical 12, and 1, 2, 3. All right, and how all it does is in this method here, this is the method that calls it. It says if n is less than 10, just print out n. So in other words, if it's just like 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, then obviously that number is going to be that number. So if it's not, what we want to do is say writeVertical and divide by 10. System.println n mod 10. So if we run this, right, you can see with writeVertical 3, it just outputs 3 because 3 is just a single line. If we do 12, it outputs 1 followed by 2. If we do 1, 2, 3, it does 1 followed by 2 followed by 3. So the task to be performed by writeVertical can be broken down into the following subtasks. So we have our simple case. If n is less than 10, then just write the number to the screen. After all, the number is only one digit long, so the task is relatively trivial. And then we have the recursive case. If n is greater than or equal to 10, then do two subtasks. 1, output all the digits except for the last digit. And 2, output the last digit. So for example, the argument were 1, 2, 3, 4. First part would be 1, 2, 3, and the second part would be 4. This decomposition of tasks into subtasks can be used to derive the method definition. So subtask 1 is obviously a small version of the original task, so we can implement this subtask with a recursive call. Subtask 2, of course, is just the simple case we listed previously. This is an outline of our algorithm for the method write vertical with the parameter n given by the following pseudocode. So if n is less than 10, system round to n, if n is 2 or more digits long, else write vertical, the number n with the last digit removed. This is now read by the last digit of n. Now, if you observe the following identities, it is easy to convert this pseudocode to a complete Java method definition. N divided by 10 is the last number n with the last digit, and n mod 10 is the last digit of n. So, for example, 1, 2, 3, 4 divided by 10 evaluates to 1, 2, 3. Add 1, 2, 3, 4 mod 10 evaluates to 4. So let's see exactly what happens when the following method call is made as in recursion demo 1. Write vertical 1, 2, 3. When this method is executed, the computer proceeds just as it would with any method call. The argument 1, 2, 3 is substituted for the parameter n and the body of the method is executed. After the substitution of 1, 2, 3 for n, the code to be executed is equivalent to 1, 2, 3 is less than 10, a system on that line, 1, 2, 3, else write vertical 1, 2, 3 divided by n. This is a print line 1, 2, 3 mod n. However, because 1, 2, 3 is not less than 10, the else part is executed. However, the else part begins with the method call write vertical n divided by 10, which, because n is equal to 1, 2, 3, is the call write vertical 1, 2, 3 divided by 10, which is equivalent to write vertical 12. So you can see how it keeps cycling around, because there's not like a loop really here to kind of do this. It's kind of a way you can think about it. It's kind of like it looping itself, but we're doing what's called a recursive call. Now, when execution reaches this recursive call, the current method computation is placed in suspended animation, and this recursive call is executed. When this recursive call then is finished, the method of the suspended computation will return to this point, and the suspended computation will continue from this point. The recursive call write vertical 12 is handled just like any other method call. The argument 12 is substituted for the parameter n, and the body of the method is executed. After substituting 12 for n, there are two computations, one suspended and one active, as follows. So you can see how this kind of stacks up here, so the computation will stop here until the recursive call returns. Because 12 is not less than 10, the else part is executed, and as we already saw, the else part begins with a recursive call. The argument for the recursive call, of course, is n divided by 10, which in this case is 12 divided by 10. So this second computation of the method write vertical is suspended, and the following recursive call is executed, write vertical 12 divided by 10, which is equivalent to write vertical 1. At this point now, there are two suspended computations waiting to resume, and the computer begins to execute this new recursive call, which is handled just like all the other previous ones. The argument 1 is substituted for the parameter n, and the body of the method is executed. At this point, the computation looks kind of like the following. So you'll notice that we have no recursive call up here. And then, of course, we now have this down here. Now, obviously, we do 1 divided by 10. We're going to get 0. So, when the body of the method is executed this time, something different is going to happen. Because 1 is less than 10, the Boolean expression in the if else statement is true, so the statement before the else is executed. That statement is simply an output statement that writes the argument 1 to the screen, so call write vertical 1 writes 1 to the screen and answers without any recursive call. When the call write vertical 1 ends, the suspended computation is waiting for it to end, resumes where the suspended computation left off, as shown by the following. So now it's resuming here, so it can now work on this print line statement. When the suspended computation resumes, it executes the output statement that outputs the value of 12 mod 10, which is 2. That ends that computation, but remember there's another suspended computation waiting to resume. And when it resumes, the situation is going to be this, 1, 2, 3 mod 10. When this last suspended computation resumes, it's going to output the value 1, 2, 3 mod 10, which is 3. And the execution of the original method call ends. And sure enough, the digits 1, 2, 3 have been written to the screen, one per line in that order. All right, and that's going to wrap up that lesson for today, folks. So hopefully that helps give you a good fundamental understanding of recursion. When we come back next time, we will take a closer look at recursion so you can really kind of sink your teeth into it. Until then.